So our team, my name's Adam Hughes, Justin Zarb, and then Pasquale Zitos. What we tried to do is take natural language processing and combine it with the maps that we use. So all of us use maps every day. Most people use Google Maps or Apple Maps or something like that. We rely on it for our transportation. There's probably not a hand in here that didn't rely on it to, get around sometime this week or something, and also to find places to eat and various other things. So, branch of artificial intelligence that that allows computers to interact in the same language that humans do. So, in a way, is there a way to create a bridge between the mapping world and the data that we have in the mapping world and our normal language? So, geographical information systems have been around for a long time, but they're difficult to use and difficult to learn to use the interface as well. So with bringing these together recently, the large language models have been developed, like ChatGPT, and not only are they good at creating human language, but they're also good at creating computer code. So what we're going to kind of delve into here is how do we use these queries to access mapping information, and especially in the OpenStreetMap world, where we have all this data available to us and we can use it. So let's start off with combining GIS and natural language processing.
Thank you, Adam. Thanks for the intro on maps. One topic which is partly my background is resilience planning, some topic that is trying to be solved right now. Wealthier countries are throwing lots of money into this problem, but it's extremely complex. And the image on the left is an image from the Berlin Climate Resilience Plan, highlighting hot regions and regions under heat stress. But that's the resolution we're dealing with. It's not great. It's not enough information for planners to make decisions at a local level. And actually, this decision-making insights would require lots of levels superimposed on top of each other. Bigger problem is that the countries affected most by climate change do not have the resources and know how to develop these tools. But there are open source platforms like OpenStreetMaps. Let's take a step back, though, and talk about Google Maps. Everyone here has probably used Google Maps. It's the most used app for finding directions and real-time updates. But if you search for drinking water fountains in the city, you'd get a few. And then if you search for the same on OpenStreetMap, you'd get even more. And this is because OpenStreetMap is an open source project, as the name suggests, which means people can contribute and add information points, which means the number of people inputting data is much larger. The big problem with OpenStreetMaps is that it's hidden behind a special query language called Overpass query language, which is different to SQL or any other commonly used languages. So there's this massive amount of data, not completely organized, and then to top it all, it's locked behind a quite complex language. This is Overpass Turbo. It's the go-to web interface with a wizard to help you make queries in Overpass query language. But if you enter anything more than a simple keyword that matches text in the database, it will fail. So this is the starting point. To summarize, these rich data require technical experts, GIS experts, to access. They're distributed on various platforms. OpenStreetMap is one platform, but there's also many city-level platforms or country-level platforms that would need to get connected. And they have these languages, and that's the problem we try to overcome in the project. So the ground project: start up our computer, open ChatGPT, and ask it to write an Overpass query, which could give us a certain result. And we realize it kind of works. So just opening these two separate browser windows and ask for a bit of code. And this is a known thing. ChatGPT is good at writing code scripts. And of course, it's hit and miss, but this was our ground zero. Then the tools that we found today. So we didn't realize when we first started working on these projects that we decided to work with things that had been released the previous week. We kind of figured that out 10 days later. So OpenAI, for those of you who don't know, is the parent company of ChatGPT. They released ChatGPT 3.5 Turbo, which is fine-tuned to run function calls from the chatbot. And LangChain is a little bit older. It's 9 months old. 6.6K forks. It's hugely under huge development repo because it basically offers a framework for chaining language models with other tools. So makes SQL calls or using Wolfram Alpha, because language models in themselves are very good at language tasks but can't do anything else. So there's a huge potential and huge power in combining these things. And one of the tools that we found that we thought would be really useful for our project was the Plan and Execute agent. There was a paper in May about it, and on LangChain there's an implemented version that's 3 weeks old. So this is the environment we worked in, all very, very new and very unstable, and one example on the website. Our first attempt was a simple chain. So basically chaining 3 steps where the user gives a prompt to the language model. The language model receives some additional prompts on what to do with the message, and creates an overpass query, gets the result, and gives an answer. And the second approach we tried is a plan and execute style agent. So this is here system steps in. So we as the developers give additional prompts between user prompts and function calls that tell the language model first to create a plan and then execute that plan. And this is what we're going to try to demonstrate now. Right, so first thing it does is creates a plan. That's the first step. And it also can return a function call in its first step. So it's started the first function. And this is the second. So it's run the getPlaceInfo function call, and it's returning multiple tags. And now it's the getPlaceInfo is the first supplementary function we created besides the overpass query, because we realized that although it has some idea on how to write a query, it has no idea on what exactly is queryable. So we're trying to create functions that fetch something, create a view of a position, and return more information back. So feeding more information to the language model to improve the next prompt. So we got to the end of the prompt. It got close. It knows there's tags for tourism artwork, and artwork type is public art, and apologizes politely. Let's see if it marked anything on the map. No. Well, but it wasn't the worst thing. Just to give you an idea of what's possible, we also created a manual explorer to really understand what's around. And this is just looking around here and printing the tags from OpenStreetMap. And even if you just look for a bank and a cafe and a cinema, for example, and add them to the map. So this is where we'd like to go and the next steps in our process. So Outlook. The models the tools we use, were very, very new. Would like to continue this project. First thing I'd like to try is develop a LangChain tool in LangChain speak, which properly can speak to overpass. Would be nice to fine-tune a language model to make more reliable queries. More about that on the next slide. And also try reinforcement learning with human feedback on the entire task. So that the entire chain can be scored. We can score the plan, the overpass query result, and then the post-processing. And these are all parts that can be scored. As we've been developing the app and testing everything, we've been bootstrapping our own data set. So we have I have on my machine about 600 queries. Most of them you can see, success rate is below 50%. So blue is the total queries with different temperature. Temperature is a parameter you can use on the language model. Lower temperature works better, so let's focus on these two. With lower temperatures, the GPT produces valid queries, but a lot of them still return very few results. And I'm wrapping up the last few seconds. Where would we like to go in terms of features? We'd like to be able to answer questions like how well are cool spots distributed in the city, and which public areas are not within reach of water. These are questions that urban planners and city planners who we spoke to are asking themselves. Taking inspiration from some great projects, the Erfrischungskarte Berlin and Parasol Navigation both leverage microclimate data to find for place finding and wayfinding in the city under the scenario of a heat wave. And another great set of open maps is the Umweltgerechtigkeit map. With these, if we integrate these maps into open maps, into NaturalMaps, sorry, would be able to search for places in quiet areas in Berlin or places with low air pollution. Think about the applications that could bring. And of course, there are other commercial applications to this chaining of language tools and maps. For example, filtering customer interfaces, which on map-heavy products, real estate, retail site selection, insurance and risk management. These are all kind of interlinked and have a very strong geospatial aspect. So that's it. Thank you very much for listening. And thank you to Data Science Retreat, all the amazing teachers, and our tutors, Marcus and Krzysztof.